Okay, so I'm going to give you again a background on the project now, supported by the slides, so you can internalize this even better. So I will talk about identification and prioritization of chemicals associated with plastic packaging. As you know, global production of plastics has been rising exponentially since 1960s, and actually in 2015 around 380 million metric tons of plastic has been produced, and astonishingly around 40% of this is used to make packaging, plastic packaging. And plastic packaging is actually hailed as a wonder material for many applications, including packaging. It is relatively cheap, it is lightweight, it is durable, it is versatile, so you can have many different properties, so you can use it in many different applications. So, there is a but. Also, because it is so durable, it actually persists in the environment, so everybody knows about this problem. But it's not only the physical pollution of the environment, it's also the fact that plastics can leach chemicals, some of which can be hazardous. Especially plastic packaging has a relatively high exposure potential for both human health, for both humans and the environment. So if you would think, for example, about plastic food packaging, which is used quite a lot, it is in direct contact with food, so the chemicals can leach into food and lead directly to human exposure. Also, you know, of course, about the environmental pollution. All this packaging can then end up there. And for example, the European Parliament report reported that around 50% of marine litter is actually single-use plastics, and among the top 10 items which are constituting this amount here, you actually can see quite a lot of packaging items, so the drink bottles, wraps, plastic bags, food containers, and so on. So this is a type of an article, a type of a product that we specifically wanted to focus on, and that's the rationale for it. If you think about hazardous chemicals in plastic packaging, I mean, everybody heard the words like bisphenols and phthalates and anil phenols, maybe heavy metals. There are many, many others which are not so widely used, but there are works also, you know, looking at them specifically. And we were kind of having a feeling that there are many more which we actually do not know, but we would like to know. Because to properly assess those chemicals and to properly manage them, also in terms of increased recycling rates, which are now, it is important to know which chemicals are there that are hazardous and should be maybe looked at and managed. So, we had this project to actually address this data gap. We wanted to know what are the chemicals in plastic packaging. And one of our main aims was to raise awareness for the issue of chemicals in plastic packaging, so that you not only talk about, you know, all the other issues, but you also realize that there is this invisible danger coming out, potentially. So we wanted to identify chemicals associated with plastic packaging. We wanted to assess their hazards and identify potential candidates for substitution. And we wanted to perform human health and environmental risk assessment for selected substances as much as our capacity allows in this short 2 years. So, I will talk now about this first part, identify chemicals associated with plastic packaging. And actually, if you think about this, this is not a trivial task. So, plastics itself is actually a complex mixture of very many different chemicals. So you have, first of all, this so-called intentionally added substances, which are intentionally used to actually produce your plastics, also the final article. So what happens, you have monomers, which are then, you know, making the polymers the base of plastics. But you can, of course, have some residual free monomers in the plastics. You have additives, which are added to plastic products to impart certain functions, like stabilizers, colorants, you know, and they're also present then in the final compounded material. You also have things like processing aids, which are used during the production process, but you can have some residual components which are still present in the final article, like, for example, solvents. But I hope you've noticed that apart from what we've just added, you also have a lot of things which have not been added before, and these are the so-called non-intentionally added substances, which can also be quite a lot. So you've got the impurities and contaminants, you've got the ligamers, reaction byproducts, side products, also the breakdown products when your plastic product deteriorates with time. So to give you more insight into this, we have a dossier prepared by my colleague Birgit Goike, and some printouts are also outside, but you can also freely download it on our website to actually have a look into these non-intentionally added substances, which were not the topic of the project here, because these are just too many and there is even less information available than what we have here. So what we wanted to cover was basically this part here for the plastic packaging. And another problem that we had to deal with is that when you think about final plastic, the plastic article, it can be rather simple. It can be made maybe of one polymer type, of one type of material, but you can also have items which are made of two polymer types, which is also important to realize when you're doing recycling, that it's not just one type of material, you have actually very many. And what's more, you also have other components. So not only plastics, you've got printing inks, you've got adhesives, foils, coatings, which are also, these are integral parts of plastic packaging article. And you have to think about these chemicals when you're talking about, sustainable plastics, recycling plastic items, and so on. So this was all that we wanted to take into account. Well, especially we focused on adhesives, foils, and coatings, so they were included in the database that I will present just next. We came up with this database of chemicals associated with plastic packaging. So basically what we did there was not a rocket science. We just looked around what was publicly available in the public domain on the topic of chemicals used in plastic packaging. So we compiled those sources together. We covered both food and non-food packaging because, especially if you think about environmental pollution, you cannot differentiate between the package which was used to package food or the shampoo or whatever. And so it's like, it's all coming together. And we identified in the beginning around 4,000 chemicals which could be associated with plastic packaging, but the challenge we had to deal with was insufficient transparency and lack of information on the actual use and levels of chemicals in plastic packaging. So we did a more detailed analysis as much as we could, and we split our database in two lists. So list A lists chemicals which are likely associated with plastic packaging, around 900 chemicals for which we are, more or less certain. And then there is the list B of the chemicals possibly associated with plastic packaging. So there is some indications, but we didn't get any clear source saying yes, it is used. So we then wanted to know what are the hazardous chemicals among those ones. So we only worked with list A, only this 900 chemicals. And we checked what is available in terms of systematic hazard information for these chemicals. So you see that, quite, up to maybe 1/3 of these chemicals had some information in terms of GHS-aligned classifications. So GHS is the globally harmonized system for classification, hazard classification and labeling of chemicals. So using that information, we also then added several conservative sources which identify endocrine disrupting chemicals, like, for example, identification within European Union. And we also added sources identifying persistent, bioaccumulative, and toxic chemicals. These were just a few. And so based on these sources, with some overlaps, which you can see here between the different chemical groups, we identified a list of 148 highly hazardous chemicals likely associated with plastic packaging, which we think should be dealt with and considered as candidates for substitution. So there are around 60 hazardous to human health and environment, around 35 EDCs, 7 PBT substances used there. And what are the functions of these chemicals in the packaging? Because of course, when you try to think about substitution, you should understand whether this chemical is needed, what is its function, can you use it for something else, can you drop it, and so on. So you just hear, I don't have time to go into much detail there, but of course there were some monomers, which are reactive chemicals, but you also had quite a lot of additives, of which maybe you might think, like, whether you really need that, and so on. So that's just, the substitution will be talked about later in this today. I will just move on. First, I always get questions because we covered both food and non-food articles. People ask me, and so how many of them are used in food contact? These are maybe just all for shampoo bottles, so it's not so critical for humans. Well, actually, we analyzed our database, and so from these 900 chemicals, so around 800 are actually allowed in food contact. And also among the hazardous substances, you can see that the majority of them are actually allowed in food contact at the moment. So, it's not only, anywhere, but it's just, maybe it's because we use the sources. I don't know. It's just the state now in the database is that, majority of the chemicals we are talking about are also allowed for food contact. And another thing I wanted to point out is, as I said, we used this conservative sources of hazard data. We wanted to be, use everything where everyone agreed on and so on. So we used only the harmonized hazard data. But if you use, for example, modeling approaches, for example, the advisory classifications issued by the Danish Environmental Protection Agency, you can see there is around 100 chemicals more, which are considered also to be hazardous in terms of CMR substances, so carcinogenic, mutagenic, and toxic to reproduction. So that would add even more chemicals there. But since they lack harmonized hazard data, we cannot actually, talk with certainty about them. So it's just a call to regulators to actually, to not lag behind so much behind science and kind of try to, to give us a basis to actually work with things. We need someone to, to accept those classifications, to say, okay, these are now accepted and taken on. Yeah, and I still have some time, at least that's how it looks. I'm going to talk now about prioritization, because we wanted also to work with some chemicals to see whether they can be prioritized for substitution, whether substitution is possible, and so on. And as you remember, we've got this list of 148 chemicals. You cannot work with all of them at once. So we wanted to choose some to continue working on. And so for the environment, I have to say that prioritization is basically a subjective approach, and your outcome depends on the criteria that you choose to prioritize. So, different agencies, different groups use different criteria. So here's what we used to prioritize environmental chemicals. First, we took the ones which had the highest score for the environment. So there's 68 chemicals hazardous to environment. Then people were looking if there is, detailed data available for these chemicals. And there were some additional cutout criterion. And in the end, the environmental assessment group just ended up with just one substance, which they looked at in detail, which is benzyl butyl phthalate. But there were also, 6 other chemicals which were highly on top of the prioritization, which are maybe the focus of future efforts. And the same for the human health. There we used different prioritization requirements. First of all, we looked for which chemicals biomonitoring data is available, so which chemicals are actually known to be measured in human organism. Then there were other considerations with regard to regulatory status, addressing, and so on. And what was surprising is that this list actually came out again with phthalates, so including the benzyl butyl phthalate, already highlighted in the environmental prioritization, and 4 other phthalates. And I will not talk more about this now. You will have, coming talks just right after me, talking more in detail about this. But that's just for you to know how we came from our 148 chemicals to this list. Yeah. See, I'm talking fast, so I managed to come to my take-home messages already now. So what I want you to carry out from this, it's published. You're very welcome to read the paper to understand all the limitations, assumptions, and all the complex stuff behind this. But what we found out is that there are numerous hazardous chemicals associated with plastic packaging. Harmonized hazard data is missing for many more substances, and basically you have to realize that when we do prioritization, we only do it for those chemicals where we have the data. The ones which have no data, they're not included, and it's a bias which is introduced by the lack of data in this regard. And there is high complexity and lack of transparency on the use and levels of chemicals in plastic packaging, and they actually hinder comprehensive overview and risk assessment. We've highlighted phthalates as immediate candidates for substitution, but there are probably other important chemicals that we should be looking at, and we need more capacity to address this. And the last point that I want to mention again, there are these non-intentionally added substances which pose unique challenges for systematic identification, toxicity testing, and risk assessment. And again, they were not addressed in this project, but they will be subject of future efforts. Maybe. So, these are all the partners on the HCPP project. Many of the faces you will see among you here. I will not mention them. Thank you to MAVA for funding this project. Thank you for your attention, and check the information on our website.